Okay, folks, this is the second part, and we're going to be talking about rational functions in this particular lesson video. But before we do that, I need to come back to something that I did before. And I showed you this graphic organizer that has to do with the end behavior of functions. And what I need to do is I need to tell you another way to understand this direction is rises to the right, falls to the right. This direction would be rises to the left, and this one would be falls to the left. And I hope that may help you. All right, let me turn my camera off. All right, on the polynomial functions, I didn't get a chance to finish this, so I'm going to do this real quick. We know that the zeros are 0, negative 2, and 1. The leading term is x cubed, so the shape goes this way. So if we were going to graph this, we have a 0 at negative 2, we have a 0 at 0, and we have a 0 at 1. Okay? All right? So guess what? This tells us that the curve has this general shape. So it's going to go up this way, it's going to go down, and it's going to go this way. Okay? And how do we know that? Because all these powers are 1, it crosses at those points. You see how that's a very powerful idea? Now you could try to graph that on your graphing calculator and see if that shows you the same thing. Now that little bit may have blown you away there, but it really is very powerful. So let's do this one. Could you graph this? Well, what are the zeros? That's a 0. Now this is 3 is a 0, but wait a minute, look at the multiplicity. 3, that means it scoots across the x-axis. This is a 2, so that means it turns at that location. All right, now could we, let me get another color marker here. Okay, if I mark it up again, would that be remarkable? Sorry. All right, now let's see. 0 and 3. 0 is right here. 1, 2, 3. Okay, 3. Now, we can mark the zeros. 0 is a 0, and 3 is a 0. Now, let's look at the leading term. That's x cubed. That would be an x squared, so x to the 5th. Would that be a positive before it or a negative before it? It would be a positive. So it follows the general plan of x cubed. So guess what? This means that the curve or the function is coming up this way. Now, what does it do at the 0? It crosses, but it sort of scoots across, okay? Now, what does it do at the 3? It turns. Well, now, how am I going to put these two together? Well, the only way to do that would be we could pick a couple values here, right? Okay, that would be helpful. But it's going to go like this, okay? I don't know. That's exciting to me, okay? That you could understand what's happening with the function. I hope that helps. Okay, now what I want to do is to just explain the general shape or form of a rational function. Imagine you were at an intersection, and so here you are. This is like a street map, street view. Okay, you get a little guy and you put him down there. Anyway, so you're going to be standing next to this person, and he's going to be walking down the street. So you're standing next to him with a ruler, okay? And then this person's walking down the street. Okay, so you have this ruler and you're trying to measure the height of the person, well, his apparent height. Now, wouldn't you agree, as the person moves further and further away from you, here's 10 feet, 20 feet, 30 feet, and so forth, the apparent height, he's getting smaller and smaller, okay? Now, the question is this. Will he ever go away if the road continues forever? No. So, his height and distance from you, it's going down like this, okay? So, that is an illustration of the idea of a rational function. What we're going to do is we're going to use this setup. Notice here's my function, and I have a table of values, okay? And then we want to graph it. Okay, so what we did is we computed the numbers. Now the problem is this 0 right here. So whenever I have a 0, 1 over 0, we know that that is undefined. Okay, there is no value there. So that is important to keep in mind. Now let's plot the points. Here we plotted the points. Now we could draw the curve of the function. Okay, remember it keeps going this way, keeps going this way, keeps going this way, keeps going this way. All right, let's tell everything about it sort of quickly. Domain, all real numbers except 0. Range, all real numbers except 0. Here it's decreasing, and here it's decreasing. Okay, and there are no intercepts. Now we have some lines that the graph approaches but doesn't touch. There's a horizontal line, y equals 0, and there's a vertical line, x equals 0. We're going to call this a VA, vertical asymptote. We're going to call this a HA, horizontal asymptote. So keep that in mind. All right, now consider the end behavior. As x approaches infinity, y is approaching what? Well, it's approaching that line, 0. As x approaches negative infinity, the function is approaching what? Well, it's trying to touch that line over there, y equals 0. Okay, now this next part's a little tricky. This is saying as x approaches 0 from the left, and this is saying as x approaches 0 from the right. Good way to understand this would be, notice over here my numbers are getting closer and closer to 0, and I'm approaching it from the right side. Now what's happening to the values of the function? The values are getting really, really high, okay? If it was 0.1, it would be 10. If it was 0.01, it would be 100. Now I could do this all day. What is going to happen to the y values? Well, the y values are going to get big and big and big without bound, or y is going to approach infinity. Now, how about over here? Well, as x approaches 0 from the left, so notice these are negative numbers and they're getting negative big. So I would say y is approaching, or negative without bound would be negative infinity. Okay? So those are called right hand and left hand limits, or right hand and left hand end behavior around a value. Okay, so let's put some things together we've studied, students. This is a rational expression, and I could rewrite it as this. Could you tell me some things about this function? In other words, could you possibly graph it? Well, let's see. Here's my coordinate plane here, okay? Now, I'm looking at the bottom, and I notice that -1 would be a vertical asymptote. So what I'm going to do is I use green for vertical asymptotes, okay? All right. And now we're trying to find any horizontal asymptotes. Well, if we notice over here at the top, horizontal asymptote, I'm going to come to that in a second. But can we plug in a 0? Let's plug in a 0 to the function. 0. That's going to be 2 times 0, which is 0 minus 1 over 1. Well, that's just -1. What is that telling us? It's telling us that the point 0, -1 is a point on the function. Okay. Now, on the horizontal asymptote, I'm just going to kind of give you the quick rundown. If the highest power are the same, then the horizontal asymptote is just the coefficients. So 2 over 1 is 2. Y is equal to 2. So y equals 2 is the value of the horizontal asymptote. Well, guess what? This point is a point on the function, and it can't cross this line, it can't cross this line. So the function's probably going like this. Okay? Now, I need to know where the function is. It could be here or it could be here. I'm going to have to pick a value, so I'll just pick -2. So I plugged in -2. Here's my numerical expression. Negative over negative is a positive, okay? So 5, -2, 5. Now that's way up there. But remember, the function can't cross the green line here. It can't cross the green line there. Now you could graph that function on your calculator, and it should match this particular picture. Okay, I need to give you the gist of horizontal asymptotes and rational functions. Here are three cases. Look at the power of the leading terms, the variable of the leading term. Here, the bottom was higher, so the horizontal asymptote is y is equal to 0. Here, they're the same. So whatever these coefficients are, let's just say that that was 3 and that was 5. Believe it or not, the horizontal asymptote would be the line y is equal to 3 over 5. Now here, the power at the top is higher, so there's no horizontal asymptote. Now, if the power is higher by 1, in this case it is, there is what's called a slant asymptote, which I will try to get to in a later video. Now, the question is can we put all of what we learned together in this one problem? Can we find out information about the problem by looking at the top and the bottom? Can we find asymptotes? Can we graph it? And then we can see what it looks like on the graphing calculator. Okay, so I just rewrote this in factored form. Now, what do we know? Well, you may want to think that x equals -2 is a vertical asymptote, but notice I have that factor up here at the top. Now, if I cross them out, then I would have a different function, wouldn't I? But remember, these are part of the original function. So what that means is x equals -2 is not defined for this function. It's not in the domain of the original function. X equals -3 is a vertical asymptote, and x equals 2 is a 0. Now what about the horizontal asymptote? Well, notice the coefficients of the leading terms, 1 and 1, and notice the powers, okay? They are the same. So the horizontal asymptote is y is equal to 1. Now the question is, can we graph this without using a calculator? Okay, so if you notice, okay, so here I have a 0. I plugged in a 0. I got a -0.6. That's right here. I need to know what happens over here on this side. So I need to pick a point. I'm going to pick -4. If I plug in -4, I have it 6. And 6 is way up here, okay? Now, I can't cross the green line, so this is going this way, and this is going this way. And the function probably goes like this and up this way. Now, let's graph it on the calculator and see. Okay, I set my window to see if I could graph that. And so here's my window. I plugged in the function right here, and now I want to graph. So notice that that graph does look like what we had. Okay, there is a vertical asymptote at x equals -3. Now let's do this. Let's just try to use the trace key. If I plug in -4, will I get that 6? What if I plugged in -3? Okay, notice nothing is here. It's a vertical asymptote. And now that value that it couldn't be, which I think was 2, okay, no, it's -2. Plugged in -2, and even though there is a -2 here, it's not showing the y value, which indicates to us or reminds us there is no definition of the function there. And what is the horizontal asymptote? Y equals 1. So I plugged that in my equation editor, and lo and behold, that does work. So there's a good example of how to understand a rational function, graph it, and see if it makes sense, making all the necessary connections. So as we finish up, could you graph these by hand? Well, here we'd have a vertical asymptote at x is equal to 2, okay? And there would be a horizontal asymptote of y equals 0. Here, we'd have a horizontal asymptote at y is equal to 2, a vertical asymptote at x is equal to 0. Now, you'd have to, show all the information, follow the lesson material, do a sketch by yourself, and see if the calculator verifies your work. Wish you well with it. It takes a little time, but best wishes.